So here we are today looking at exponential equations. This is a little bit of a strange one. We're actually using logarithms to solve these, but I'm going to show you a bit of a cheat to be able to solve them. So just use that for now, and as you go through your maths and in kind of year 11 and 12, you'll start dealing with logs with these questions. Love a bit of a cheeky base 2 power, always easy to work with. I've put up a document about some useful bases and powers and various indices as well, so check that out if you're not very confident with some of these. But basically, if we have 2 to the power x, we can also write 32 as 2 to the power 5. So pretty clearly, we can say x equals 5. If you want to know the technicals of what's occurring there, so if you're really keen, we're actually applying a log law like this to 5. We can actually bring our x's down the front, our powers down the front, so this becomes x log 2 of 2 and 5 log 2 of 2. And a log base of any of the same value is just 1, so effectively these cancel, leaving us with x equals 5. You don't need to know that part, you just need to get to the same base and work from there. So I'm just going to erase all that now. Let's have a go at question B. So we can write this as 3x and 1 over 27. That's the same as 3 to the power 3, but being a fraction, we need to do a negative there. So we can now see x equals negative 3. So question C is a little bit tricky. As you can see, there's a bit of a trick here that we're going to go base 2 again. So 16 is the same as 2 to the power 4, but we've got this x there. And then we've got 2 to the power, that's going to be, 6 would be 64, so 7. Pretty sure that is right. We would then write this as 2 to the power 4x equals 2 to the power 7. We can then say 4x equals 7 and x equals 7 over 4. So getting it down to the lowest base possible, in this case 2, is a good way to go. Same thing here with question D. So we've already got 3x plus 1, and 9 is the same as 3 squared, and we have an x there as well. So now we can say 3x plus 1 equals 2x. Subtracting 2x from both sides gives us x plus 1 equals 0, and of course that comes out to be x equals negative 1. For question E here, I'm going to change our 1 over 2 to the power x to 2 to the power negative x. That's the same thing. And 64 is 2 to the power 6. So negative x equals 6, meaning that x equals negative 6. 2/3 to the power 2x plus 1. So that's going to stay the same. And this one, we can write it as 2 squared over 3 squared, but a better way of writing that will be 2 over 3 all squared. Again, they're the same thing, so I'm just rearranging it, making it look a little different. And then once we have the same base again, 2x plus 1 equals 2, giving us 2x equals equals just 1, and x equals 1 over 2. So like I said, there's a couple of tricks there. You can use your CAS to solve these, so give that a test if you're stuck on any of these problems. But you're always looking to get down to the same base, and usually going as small as you can is a good tip. So base 2, 3, 4, keep it as small as you possibly can. Even base 4, actually, you won't use a huge amount either.